Okay. Is there anyone in here by chance who has not turned in the chapter 3 tests?
So glad.
Okay, so I think I have everybody's, and they are all graded, and the grades are posted, blah, 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 blah. So, we will go over that chapter test, starting, or next Tuesday, because we have this Thursday off, right? And by the way, the scores were excellent. I think the average was above 90. Okay, so that is fantastic. Okay, so the quiz for chapter 4 is posted. It's up, and it is due this Sunday night. And the chapter 4 test will be posted next week and will be due the following Sunday night. Everybody understand that? And remember that there's a big overlap between chapter 1 and chapter 4, such that if your chapter 4 test is better than your chapter 1 test, I'll use that grade for both. Okay? All right. So I want to talk a little bit about the format of the quiz and the test, as it were. On the quiz, which will be exactly like the test, you have to determine whether the argument is inductive or deductive, and then you have to determine which kind it is. Okay, so let's remind ourselves of all these different argument types and everything. Okay, so inductive arguments. Okay, one, we had analogies. Okay, and so remember, analogy is always going to say, and so this thing is like this other thing in all of these ways, so I bet they have this other commonality. Does everybody understand that? So there's always a comparison going on. And then we have a generalization. Okay. And remember, generalization is used in a very specific way here. It's a claim about a population. A claim about a population based on a sample thereof. Okay, so it's not just a general claim. Okay, all right. We also have prediction and probability. Okay, and to be clear, predictions are claims about the future, what will happen or something, right? And so this is not a prediction. I bet we will discover that Joe was the murderer. Okay, that's not about, hey, this is going to happen. Okay. Okay. So then we also have cause and effect reasoning. Okay, which can go from cause to effect or effect back to cause. So there is some overlap between predictions and cause and effect reasoning, because when you're going cause to effect, you're making a prediction. So I will accept prediction instead of cause and effect if it's going from cause to effect, but I won't accept prediction if it's going from effect back to the cause. Does everybody understand that? Okay. And then appeal to authority. Okay. And then the last one was to a scientific law. Okay, to a scientific law. Now, how do you know that this is an argument to a scientific law versus from a scientific law? The law is the conclusion. Okay, you're arguing to this law being true. Does everybody understand that? Okay. Now, you have to tell me if it's inductive, and you have to tell me which kind, and then you'll have to do one more thing, and that is tell me whether the argument is strong or if it is weak. Now, we know that there's an in-between ground or possibility with inductive arguments. I will try to pick some that are clearly strong and or clearly weak, okay? If you get it wrong on that strong or weak part and you want to argue about it, go ahead, because sometimes people will say, well, I was thinking about so-and-so, which made it very weak. And I'll say, okay. Does everybody understand? And so, by the way, there is partial credit. It's I don't know how exactly I have it divided up. It might be half of it is for getting this part right and half for getting that part right, okay? Now, the strong or weak, you should think about it in terms of probabilities. Given the evidence, what are the chances the conclusion is true? That's what you're asking yourself. So, given the evidence, that means assume that the evidence is true. Did everybody understand that? You're assuming it's true, and then you're saying, well, how likely is the conclusion? And let's just say, if we think that the chances are greater than or equal to 75% in some kind of rough or ready way, then it's strong. Everybody got that? So equals strong. Now, here's a mistake that people do quite often. They tend to label all inductive arguments weak, because what they do is they think to themselves, they think about the evidence, they think, oh, here's this evidence and here's that conclusion, and does this evidence support the conclusion? And they say to themselves this, not necessarily. And then they put weak, okay? But look, for inductive arguments, the conclusion is never necessary. Does everybody understand that? So if you use that standard for determining strong or weak, you're going to say every inductive argument is weak. But no, we have strong and we have weak inductive arguments. So you have to think about what are the chances. Does everybody understand that? We already know the evidence doesn't necessarily lead to the conclusion. So don't even think about that. Everybody understand that? Okay. So now let's go over to deductive arguments and remind ourselves of the kinds that we have there. Okay. One, based on definitions. Okay. So if the conclusion follows from the meanings of the words, then, well, it's based on definitions. Now, if someone is trying to trace out the meanings of the word and they do it wrong, you would say it's deductive based on definitions, but you also have to tell me whether what? The argument is valid or invalid. And if the meaning doesn't, if the conclusion doesn't actually follow from the meaning of the words, then it would be invalid, okay? So we got based on definitions, and we also have based on math and geometry. And remember, just because there's numbers doesn't necessarily mean it's math and geometry. You have to think about, is it probabilities, which are different, right? Probabilities are inductive. Math and geometry can lead to necessary conclusions. Okay. Then we have from a scientific law. Okay. And now how do you know it's from versus to? The law is used as a premise. Okay, that's from a scientific law. Okay. Now, this is the new thing, the major new thing in this chapter, and that is an argument can be deductive based on form. Okay, based on form. Okay, and so let's remind ourselves of the kind of argument forms that you should be looking out for. And we've gone over a whole bunch of argument forms. On the quiz and on the test, I'm just limiting it to 5. So you're just going to be on the lookout for these 5. Okay. Box, then circle, if box, therefore, if box, then circle, box, therefore circle. This is modus ponens. You won't have to tell me which kind, but if you see something and you mentally symbolize it and it fits into that structure, you're going to say deductive by virtue of form. Everybody got that? Also, we have modus tollens, which is box, then circle, not circle, therefore not box. Okay, that's modus tollens. If you see something that falls into that form, that's going to be deductive by virtue of its form. And then I think we have